Hi everyone, welcome to Differential Calculus. Today we explore lesson 3.5, Implicit Differentiation. Number one, the idea. In the previous lesson, we studied functions that can be expressed by one variable explicitly. And we usually written y as the function in terms of x, such as y equal to root of 2x minus 1, y equal to e to the x plus 2x. However, some functions are defined implicitly by a relation between the independent variable x and the dependent variable y, such as psi xy plus y equal e x xy square plus y x to the 3 equal 2x y. Notice that these are equations in which we cannot solve for y explicitly. So there has to be a way for us to figure out the derivative. Implicit differentiation definition. Implicit differentiation is a method of finding y prime or dy over dx by differentiating both sides of an equation with respect to x. It is always assumed that the given equation determines y implicitly as a differentiable function of x. Let's do a little review here. We know that the derivative with respect to x of x is 1. Apply the same idea to the derivative with respect to x of y, and we have dy over dx, which is known as y prime. Derivative with respect to x of x squared is 2x. Derivative with respect to x of y squared. Y is treated as a differentiable function of x. So we got to use the chain rule. Derivative of the outer function is 2y. We got to multiply by the derivative of the inner function. That is derivative with respect to x of y. So this gives us 2y and y prime. Derivative with respect to x of e to the x is e to the x. Derivative with respect to x of e y. We treat y as a differentiable function of x. So derivative of the outer function is e to the y multiplied to the derivative of the inner function y prime. Example, 5y prime. A x to the 3 plus y to the 3 equals 6xy. To do this, we differentiate both sides with respect to x. Derivative of x to the 3 is 3x squared. Derivative of y to the 3 is 3y squared times y prime. For the derivative on the right side of the equation, we use the product rule. 6x multiplied to the derivative with respect to x of y plus y times the derivative with respect to x of 6x. 3x squared plus 3y squared times y prime equals 6x times y prime plus y times 6. From here, we can solve for y prime algebraically. Move the common term to one side. 3y squared y prime minus 6x y prime equal 6y minus 3x squared. Factor out the y prime, we have 3y squared minus 6x equal 6y minus 3x squared. And so y prime is 6y minus 3x squared over 3y squared minus 6x. B, 7y squared plus e to the y to the power 3 equal 4 minus x to the 3. To find y prime, we're gonna differentiate both sides with respect to x. Derivative of 7y squared is 14y times y prime. Derivative of e to y to the power 3, e y to the 3 times 3y squared times y prime. Use the chain rule. And on the right side, we have 0 minus 3x squared. We can factor out the y prime. (14y) plus 3y squared ey to the power 3 equal negative 3x squared. And so y prime is minus 3x squared over 14y plus 3y squared ey to the power 3. Not too bad. Right? Implicit differentiation is very useful to figure out the derivative of natural log function and the derivative of inverse trigonometry. Thank you for watching. See you in the next video.